been doing a lot of thinking about, well, I've been doing more thinking about my language, as I guess you'd expect, and I have some ideas to do with the type system, particularly in making it atomic. So I'll probably elaborate on that once I have more thinking down. I could also just like show the thinking as I do it, but yeah, whatever. Right now I'm completing training for my upcoming job that I guess I technically already have. Like I signed the contract, but I just finished the training, and there's quite a bit of stuff, but that's why I may not be uploading as frequently in the coming days or even weeks, honestly. I mean, I'll hopefully be working as well fairly soon. So just a heads up on that for all my committed fans. So, anyway, obviously a few different things I could be doing right now in terms of my projects. I want to get back to my game. Like, I think my last commit on my game was 3 days ago? Or 4 days ago? 3 days ago, yeah. So I want to get back on that at some point. But right now I want to focus on something that I haven't, well, that I've been meaning to for a while, but just haven't really gotten around to it. Which is reading this book. So I can find it here. Category 3 for programmers. Especially as I think about my type system for my language, True. I think it'd be really good to read this book right now, because I mean I've been meaning to for ages, but I just haven't gotten around to it, as I said. And I wonder how I'll read it as well. I guess I do have highlighting here, which is pretty good, but I don't have notes. Like, there are comments. Oh. Oh, I can. Oh, okay, never mind. Yeah, okay, never mind. I guess Waterfox's built-in, or Firefox's built-in PDF editor is actually, or annotator is actually quite useful. I wonder if they stay on the documents though, because this is a website. So I guess I need to save it. So what I'll do is I'll save this then. And where should I put it? I could put it I could put it in my Obsidian vault directly, but I don't want to do that because it's really big, and I sync my Obsidian to Git, and Git has a limit on file size anyway, without, I guess, paying more. I mean, like GitHub, sorry. So, how does Git even work, by the way? Like, Git isn't a database, right? Like, you have to host it somewhere yourself. Yeah, to like a target, and GitHub is one of those targets, I guess. So I guess I could self-host, but I don't have the resources to do that right now. But that'd be pretty interesting, I guess. I could like self-host my own Obsidian vault. Yeah, not a bad idea. Yeah, because like I was thinking, like, if I got a Blueberry, like a Raspberry Pi and a Blueberry Pi, what would I actually use it for? And like obviously hosting is like the big thing, but then it's like, what do I host? Anya, Git projects, particularly the Obsidian Vault and other like type, like personal type things, because like my Obsidian Vault is private. It's why it's not public on GitHub. So like those kind of things I still want to version control and like back up. That's what I can use my server for. Yeah, I mean it's kind of makes sense, doesn't it? It's not free, because I still have to like set it up and buy all the components and stuff, but it is secure as well, which is pretty good. It's how stupid it is. Anyway, yeah, so this book, so for those who don't know, by the way, category theory is a cool thing. Look it up, particularly with how it's used in like, well, how it's inspired programming. Funnily enough, actually, like the Haskell, like functor, monad, monoid, although they are named after category theory concepts, they weren't actually derived from them. Like, it's not like the person who, like the people who made Haskell looked at category theory and like, oh yeah, this is so useful, let's put that in our language. No, like they first created the features, and then were like, what do we call these? Oh yeah, category theory seems to fit that decently well. Which is also why like the functor, monad, monoid, whatever, like those aren't actual, like, although like they do resemble the category theory concepts, they aren't faithful. That's what I understand in a way from my memory about the history. I could be wrong, but that's what I remember reading about. But anyway, this book then goes over category theory in general, with a programmatic or programmer-focused lens, which would be pretty interesting. And it's quite long. I mean, it's 500 and almost 500 pages in this PDF. You can see here there are many different chapters here, but I'm hoping it will, because like my goal isn't to learn it for programming per se. I want to learn category theory in general. It's more just that category theory is so abstract. Like I've tried reading it like on Wikipedia articles. It's really abstract, and maybe I could probably do better than Wikipedia, to be fair. But like as far as resources go, there aren't that many resources on it. Because it's quite a niche field of study, and it's even like kind of shunned. I mean, not shunned, but like it's kind of like scoffed at by many mathematicians because they see it as fairly useless, which is ironic because they're mathematicians. But anyway, and this book makes it more concrete by giving, I assume, concrete examples that you can understand from a programmer lens. I'm a programmer, and I believe that programming is a very good example for lots of like systems kind of engineering things, or like system design, because of how like important programming is, and like what you can create with it. Like it's very systems focused, and like code architecture, but then also like how it runs and stuff like that. So generally speaking, programming is a good example for many like abstract things, let's say. So that's why I'm excited for this. Anyway, so yeah, where to save this, right? Because if I save it to my computer, I risk losing it. Thing is, though, in my Obsidian for my Obsidian notes, I don't really need the PDF anyway, because I still put like page numbers in my notes. It just means that I lose the convenience of having the highlights with me, but usually I just kind of copy those manually by hand to my Obsidian, so it shouldn't matter. The main thing is just having it saved, so I can easily access it. This was 2023, by the way, so 3 years ago, sorry, which is not too bad, right? So let's go ahead and Control O, I think, would open it. Yeah, open that. There you go. So now this is my own local copy. I'll go and zoom in here. I do wish I could like move it to one side or something, so that my camera doesn't block it. So for now I'll just move my camera over here, down here. I'm not coding, so it doesn't really matter, does it? Okay. Part 1, Part 2, Part 3. There are parts. Are there? Oh, yeah, there are. Okay. Yeah, so January 2023, the version is a hash number. I was actually thinking about this. People were talking about it in the programming Discord server, which is how do you do version control, right? Because like you want some way to like signify major and minor releases, but then like version numbers are very vague. Or you could do like something like with Mac OS does, which give each of their major releases a name, like Mac OS Sierra or whatever, Master OS X Sierra, and whatever other ones there are, Jaguar, like I don't know. Or you could do something that's a bit more focused, like C++ reflection update, C++, or like the Rust, I don't know, let else update. But then like those are like feature centric and focus on just one feature, so that's another issue. So that's just something on my mind. But I will share this in the server because it's kind of funny. Oh, you lag. Yeah. Recording on OBS definitely can increase the lag on my computer, but well. Anyway, so let me go ahead and open my Obsidian. Look at that beautiful setup. Missing a lot of like thumbnails here, but that's because they kind of don't have ones, and it's probably not worth my time. Also, I do have notes in category theory already, These are archived notes though, so like they're from my old note-taking system, hence why it says XXX wiki. But I do have some notes already. I don't know how useful the notes are though. Like I categorize for my objects and morphisms. Like I'll probably just refer to these if I like really think I need to, but for the most part I'll just create new notes from scratch. Because this time I'll be reading from a source that isn't Wikipedia. So new notes. Here we're going to title it, well, what are the things called? Category 3 for Programmers, right? By Bartosz Milewski. How do you pronounce that? I believe it's Polish. Yeah. And the dates would be 2023, January the 30th. So include that as well. Title, Category 3 for Programmers. Author, Bartosz Milewski, the 30th of January 2023. Tags, it's a book. IDs. Doesn't really have an ID per se. Like, there's a hash, but that's not really relevant. The link, I do have the link to the PDF, so I'll link that. It's cool that it's free, by the way. I assume this isn't like a piracy thing, like it's literally hosted on whatever this is. If it is, then I apologize, I wasn't aware of it. But either way, I'd probably find a way to access it for free anyway. That's pretty cool. Let me put some mirrors as well, just in case. Category theory, programmers. Like, where's the official page? Is it even printed? I don't think there's a physical release. Oh, there's one, okay. But it said yeah. Like £290 is quite ridiculous. So clearly it's quite sacred. Like, what the hell? But here's the official website. And this was 2014? Yeah. So like, it is available in a digital format. But I believe it can also be sold. So I'll put this as a mirror. But this one was 2014, so it's also an older version, I guess, which is not ideal, but whatever. And for our preview, we should be able to get a nice picture here. Why did it copy paste properly that time? That's weird. Yeah, this be the cover. Although I'm not sure I need the spine. Is it like a good quality cover? Yeah, why does the PDF have no like cool cover? Okay, just checking out that there are actually images for this as well, because I do like I think the images make it a lot more of a nice read. Alright, there's the cover here. In decent quality. Right, just paste that. That's a link? What? It said copy image, not address. There you go. Copy that, open that, and preview at the end, because it is indeed a preview. And then paste that there. And now we're ready to start. There's all my sources. There you go. Then yeah, just open NeoVim. So I'll go documents / my brainlet. That's the name of my thingy. Open that in NeoVim. And what's the difference? Okay, let me just add this. Create new diary entry. I mean, yeah, there's more to it than that, but anyway. And then let's go ahead and I think it's just PF for this one. Category 3 for programmers. That's the wrong folder actually. Okay. For this one. Yeah, so I actually already have a note for this as well. I'll just find that again. I'll click this and go back to the other one. This one, yeah. I can open that in thingy. Right, so I had this before. Yeah, so it was compiled into a PDF by permission. So I would actually copy this description. I think it'd be pretty good to have. So it's a book by published in 2018. So originally published in 2018. Now just save that. Go back to this one. I should probably get text wrap at this point if I want to be serious about using this. So let me also open my config. Go to my options. I kind of need to reorganize this, but anyway. Right, yeah, so I've wrap as false. I can set this to true optionally. Generally, I don't want it, but I can enable it for, I think, just some files. So, how do I enable text wrap in NeoVim, but only for Markdown files? Yes, it's auto command. That's it. Okay. Let me just mute that. Yeah, so I'll do an auto command. So, API, create auto command, patch it Markdown, wrap and line break equals true. Okay, so it's both, I guess. Vim.opt local. Right, and then I have to use opt local. Okay, that's fine as well. So vim.api dot nvim auto command create auto command. There. Just getting used to the keybinds here. File type. I wish Lua had enums, because it says like it seems like you have to use strings for a lot of things, which is not, well, it's not ideal, is it? Don't know why it didn't give me automatic indentation there. So patch it equals Markdown, and then callback is a function. That's weird. Ops equals, huh? Wait, what? Oh, it's okay. It's an object. Right, and then vim.opt local dot wrap equals true, and then same for line break. It was right. Yeah. Okay. So now if I go back to NeoVim over here, right, and then let's say I quit, open up again, category theory for programmers in sources here. And we have text wrap. Nice. Perfect. It does mean it does make things a bit awkward because like I can't go down to 4, and if I create a new line, like it goes past it. So like that's a bit that takes getting used to. But honestly, like just use like, now that I have Flash on NVim, it's so much easier to like navigate. Like let's say I want to go here. Where's my mouse? Here to additionally, I can just do SA and P and boom, I'm there. So that's very useful for like this kind of text editing. Text editing. There's something else I wanted to do real quick. Yeah, that's fine, I guess. So save that, quit that, and add, enable text wrap for Markdown files. Okay, close that, go to this, and I'm going to use the toilet real quick. I got distracted looking at this discussion about how a language's standard library works, and how you don't want to have like, well, like just really like what should a standard library include, and how often should it break things, right? Because I'm of the opinion that a standard library should really try to include as much as it can. You know, like if you can standardize JSON parsing and HTTP stuff, you know, or like even GUI, possibly, then do it, you know, standardize it. But like only if it makes sense to standardize it. Like I said, GUI. Like GUI is more opinionated because of how the GUI could end up looking, right? If you want to have a standard GUI standard library, then you want to use a fairly unopinionated one. So like very like, you know, so like if I include well, like look at HTML, right? If I make a HTML page and I open it in my browser, it's probably going to have some like default font, you know, so it's going to have no styling whatsoever. Maybe there'll be some like default padding on like the page layout, but otherwise, like if I just create like an empty or like a very simple HTML file where I only have like a header tag and like a p paragraph tag and like that's it, it's going to look very primitive, right? Like that kind of thing, where like the standard doesn't like impose any like default styling or anything that like has like a brand attached to it. Like no, like it's just very like bare bones, and then it adds features that can let you style it to your tastes, but like are ultimately just features, you know. Like again, like they're not opinionated. They don't say like, I don't know, like the default font would be JetBrains Mono or something. Like no, it would just default to whatever your system is, and you know, like a header would be this size because like that's just a bit bigger, you know. The color would be like probably just be black, right? And like whatever. Very much like HTML and like CSS works, right? Like with CSS, it gives you a lot of tools, but like it would impose some like default layout when you create a new HTML project. It doesn't happen. If you want to have some kind of like default HTML layout, you would install a layout. So then, you know, on top of your standard GUI library or interface, then people could create their own libraries that do have some kind of opinions, right? Like a blog library, for instance, that sets up and styles, you know, the GUI in a particular way that fits that kind of like brand, you know. So let me clarify. It's not like that. It's not opinionated. It's more that it's not branded, right? So like it looks how you'd expect like just like a blank slate to look, basically. That's what I think of when I think standard. Like with JSON, you know, I mean, like JSON is a very well-defined format. So like there's very little reason not to have a standard JSON library, unless you're scared that you will not be able to implement it in a way that is as efficient as other ones, right? But then just like if a more efficient one comes along, then just adopt that change and then update your JSON library, and you can do that by keeping the interface the same, but having the implementation be more subject to change. And then of course, like sometimes you will need to update the interface as well. But like that should be no different from updating, you know, like a language feature or removing a language feature, right, or deprecating something. Like these can happen as a language evolves. Yes, you have then issues with people who want older versions, whatever. But like as long as you have a good version control system or like an addition system where they can target certain like versions of the standard library and versions of your language, then that should be okay. And then, you know, rather than people relying on the same JSON library anyway, and people, you know, contributing to that, you instead have them contribute to your standard library. And then, because it's like the standard library as well, you probably get a lot more attention there, get some more developers involved, and they'll be like, ooh, I get to work on, you know, the Rust projects, and work on their JSON library. You know, like, people can do that instead of saying, yeah, you know, I worked on, you know, Bill's JSON library for Rust. Like, it has more weight as well, which is pretty cool. Obviously, that's like a minor thing, but or rather irrelevant. But like, it's just like a little bonus incentive, I guess. Yeah, so that's my take on that. Like, generally, you should try to include as much as possible, but keep it like primitive. Is what I'm kind of saying. Anyway, back to the book. So, originally published in 2018. The book aims to introduce category, funky theory for programmers. Yeah, so I don't really have like these links anyway. So, category theory for programmers. I had those results there because like it was a pun, but it's not really a thing anymore because I deleted the other part. Whoops. Okay, it's also outlined in a free blog by Milewski, and it was initially compiled into a free PDF on GitHub by contributors with permission. Okay, and this is just like the like the preface comments. Okay, so with that in mind, or with that out of the way, I could probably delete this now. Yep, so I'll just go ahead and delete file. Because like really, I want to get rid of all these like old things as much as possible. Like this should be empty at some point. I don't have that many, but there is quite a few. So like they do need to be addressed. Okay, I was published in 2018. Yeah, so let's start reading. I'm just trying to think like how. Yeah, I want to like push this as much as like I can. Maybe even shrink this, because I don't need all that space. Actually, I kind of optimize it for my calendar, right? Oh yeah, but the calendar doesn't care. So it's more just about this. That way I can have this be a bit wider as well, without affecting the page layout here. Cool. Nice. Okay, let's get started. So, Category Theory for Programmers by Bartosz Milewski. How do you pronounce that? It was made with latex, by the way. It's pretty cool. Right. I guess we'll just go straight to the preface. Skip all this table of contents. So, for some time now, I've been floating the idea of writing a book about category theory that would be targeted at programmers. Mind you, not computer scientists, but programmers. Engineers rather than scientists. Interesting. I know this sounds crazy, and I'm properly scared. I can't deny that there is a huge gap between science and engineering because I have worked on both sides of the divide. I agree, but I've always felt a very strong compulsion to explain things. Especially in computer science, like, the theory is very different from the programming. It's why like a lot of people might be surprised when they go to university and realize why we're doing so much maths and stuff like that. I have tremendous admiration for Richard Feynman, who was the master of simple explanations. I do want to actually do a deep dive into Richard Feynman's things. Less so to like hear what he's teaching, but more so to check out his style of teaching and communication. Because it's very, it's very important to have good communication. I know I'm no Feynman, but I will try to do my best. I'm starting by publishing this preface, which is supposed to motivate the reader to learn category theory, in hopes of starting a discussion and soliciting feedback. Yeah. Yeah, so straight up, let me go to my inbox here, and yeah, I do a deep dive into Richard Feynman and his communication / teaching techniques. Communication misspelled, technique also misspelled somehow. Jeez Louise. Native English speaker, by the way. Okay. I will attempt in the space of a few paragraphs to convince you that this book isn't for you, and whatever objections you might have to learning one of the most abstract branches of mathematics in your copious spare time. What Chilean found it, or copious. Isn't copious just like copious amounts? Like huge amounts? Yeah, large amounts. Copious spare time. Do I have copious spare time? I kind of make spare time by not doing other things properly. That's what I should be doing. So one of the most abstract branches of mathematics. That's an interesting kind of starter there. You also watch material to live audience. Yes, there is a YouTube version of this, but I prefer reading it. So, optimism is based on several observations. First category theory is a treasure trove of extremely useful programming ideas. Okay, Haskell programmers have been tapping this resource for a long time. They have, and the ideas are slowly percolating into other languages. This process is too slow. We need to speed it up. Nice. Percolating. Filtering a liquid slowly through a porous substance, brewing coffee, having an idea of feeling spread. Okay. So spreading and develop. Right. So, meaning, spreading, and growing gradually. Slowly percolating is a bit of a repetition, I guess. Yeah. So with these notes, by the way, hopefully I can first of all see them Is it like a view where I can just see all my notes? Outline, pages, attachments, and layers. I don't know if I can, which might be problematic. But I'll figure it out. Because what I'll do after I finish taking all my notes on this is then move them to my Obsidian. And that just kind of like saves me time from switching between them. Here I can just do it. Well, like yeah. It just means I just switch between software less. Let me take my headphones off as well. Second, there are many different kinds of math, and they appeal to different audiences. You might be allergic to calculus or algebra, but it doesn't mean you won't enjoy category theory. I go as far as to argue that category theory is the kind of math that is particularly well suited for the minds of programmers. I agree. It's very different from like calculus and algebra. Like it's more interesting, I'd say, because it feels like it has more applications to real life. Obviously, calculus and algebra do, but you wouldn't really like study those things, calculus and algebra, unless you were trying to do like engineering of some kind, but like physical engineering, like physics and stuff like that. But if you're doing programming, category theory is more useful and like feels more relevant because you can use it to develop software, whereas like calculus doesn't really apply there. Yeah. And as I talk about these things too, I'll make sure to highlight, unlike calculus and algebra, which are, I can't spell, algebra, which are better suited, which are more relevant to engineers in fields like physics. Programmers benefit more from the maths of category theory, since it is more relevant to their line of engineering, software engineering and architecture. Because we don't deal with gravity. That's because gravity category theory, rather than dealing with particulars, deals with structure. Yeah. Structure is the key there. It deals with the kind of structure that makes programs composable. Yeah, which is very cool. So first note, composition is at the very root of category theory. It's part of the definition of the category itself, and I'll argue strongly that composition is the essence of programming. We've been composing things forever, long before some great engineer came up with the idea of subroutine. Some time ago, the principles of structural programming revolutionized programming because they made blocks of code composable. Then came object-oriented programming, which is all about composing objects. Functional programming is only about composing functions and algebraic data structures. It makes concurrency composable, something that's virtually impossible with other programming paradigms. Okay. So composition at the very root of category theory. Right, so I'll use a different color for these ones. I'll use like. Actually, no. I'll just use one color, to be honest. And then if there are comments I do, if it's self-explanatory, I'll just highlight it as it is, and then I can reword it later when I put it into my notes. Yeah, this is interesting. Concurrency is a big point. It's not something. Yeah. Like I haven't looked that deeply into concurrency, but it's very interesting how that works. I haven't explored that deeply into concurrency, but I'm aware that SIMD, for example, benefits from code being written in an order-independent way. Yeah. Like C++'s standard SIMD is really also applicable to multi-threading. Yeah. Third, I have a secret weapon, a butcher's knife, with which I will butcher math to make it more palatable to programmers. When you're a professional mathematician, you have to be very careful to get all your assumptions straight, qualify your statement properly, and construct all your proofs rigorously. This makes mathematical papers and books extremely hard to read for an outsider. I'm a physicist by training, and in physics we made amazing advances using informal reasoning. Yeah. Mathematicians laughed at the Dirac delta function, which was made up on the spot by the great physicist P.A.M. Dirac, I don't know that guy, to solve some differential equations. They stopped laughing when they discovered a completely new branch of calculus called distribution theory that formalized Dirac's insights. Yeah. So, like, you don't need the formal, like, syntax to make discoveries, per se, but they do make things, I guess, more standard, right? I like how it highlights both of those. Just highlight this one. It shows that we don't need the formal standardization of maths. Well, that we don't need a formal standard of communication to come up with new ideas and make breakthroughs. I would imagine it's more so that having the formal standard is particularly useful for then educating, for then sharing the understandings with others. Mathematicians laughs, yeah. Of course, when using hand-waving arguments, you run the risk of saying something which is blatantly wrong, so I'll try to make sure that there is solid mathematical theory behind informal arguments in this book. Good. I do want something like that's like robust and like standard, because like I talked before with in my last video, I tried to look into type theory, and didn't get very far just because like I couldn't find I wanted to find like those formal like vocabulary and things that help me understand other people who talk about type theory, but I find it really hard to find like an entry point into that. Like I need to learn the language of type theory in order to investigate more type theory. Otherwise, I'm just completely lost. And the same goes for everything. If there is some standard, and there should be a standard, then that, learning that would make it a lot easier to then learn the topic, right? Because like that's how that information is disseminated, is spread. So I try to make sure that I do have a worn-out copy of Saunders Maclean's Categories for the Working Mathematician on my nightstand. Oh, I don't know about that book. Have a quick peek at that. How did I... Okay. This is about category theory. Yeah. 1971. Since this is a category theory for programmers, I'll illustrate all major concepts using computer code. You're probably aware that functional languages are closer to math, and the more popular imperative languages, they also offer more abstraction power. I don't know if that's true. The languages definitely offer more abstracting power. That is true, but it's less so that it's like exclusive to the functional paradigm, and more so that the people who make functional languages were more open to exploring different ideas, and so that's how they've ended up with more abstractions. But it's not that you can't have those same abstractions in imperative languages per se. So a natural temptation would be to say you must learn Haskell before the bounty of category theory becomes available to you. It's useful, but that would imply that category theory has no application inside of functional programming, and that's simply not true. So I'll provide a lot of C++ examples. Nice. Granted, you have to overcome some ugly syntax, yep, the patterns might not stand out from the background of verbosity, and you might be forced to do some copy and paste in lieu of higher abstraction. But that's just a lot of a C++ programmer. Yep. Lucky for me then, I know both Haskell and C++. In place of. Meaning instead or in place of. Can I extend this? No. Okay, that's unfortunate. But I mean, I'm using the browser editor. I shouldn't expect too much. But you're not off the hook as far as Haskell is concerned. I will like sort out like a proper PDF editor at some point. I don't know if I ever have one right now. I guess Obsidian is one, but then I have to import it. So, but you're not off the hook as far as Haskell is concerned. You don't have to become a Haskell programmer, but you need it as a language for sketching and documenting ideas to be implemented in C++. Yeah. That's exactly how I got started with Haskell. I found its terse syntax and powerful type system a great help in understanding and implementing C++ templates, data structures, and algorithms. But since I can't expect the readers to already know Haskell, I will introduce it slowly and explain everything as I go. Okay, so I wonder if I can kind of skim through some of that. But you know, it's always good to like kind of look at go start from the roots sometimes, even if you already know what you're reading about, just because you might pick up some things and like new ways of seeing things that you didn't before. Yeah, holy moly, I love how like the ideas just come when I'm reading stuff. It's a shame I can't have like my Obsidian on hand at all times. That's why I need like better note-taking software, especially on mobile. Like, imagine having like a mobile operating system, you know, like for your phone, where like the note-taking was just integrated, right? So like I could just take like I mean, I guess I could like take like a screenshot, and then maybe add like annotations to that. I don't know if that's a thing for iOS, but yeah, having like a note-taking oriented operating system would be awesome. Yeah. Even if readers do already know Haskell, there is value in learning something from the foundations that you already know, as you might be made, well, as you might cover some gaps in your knowledge, or come to see things in a new light. Yeah. If you're an experienced programmer, you might be asking yourself, I've been coding for so long without writing my category theory or functional methods, so what's changed? Surely you can't help but notice that there's been a steady stream of new functional features invading imperative languages. No mention of Rust yet, right? Even because this is 2018, keep in mind. Even Java, the bastion of object-oriented programming, let the lambdas in. C++ has recently been evolving at a frantic pace, a new standard every few years, trying to catch up with the changing world. Has that not always been the case, though? Like, every 3 years with C++? Because you had 11, 14, 17, 20. I don't know before 11 if there was anything else, but I don't know. But yeah, I mean, it's interesting that C++ has been like particularly going fast recently. Back in the day, like C++ 11 is such a different language, but like then you had 14, 17, 20, 23, and now 26, and then later 29. You know, 29 could like introduce pattern matching, so it's very interesting. Like honestly, as C++ evolves, it like while obviously it's still used by many, like the main interest in the language kind of shifts from being like the language I can use to write fast software to really being like a case study of like how a language can evolve without breaking backwards compatibility, and that's really interesting to look at. I mean, just look at like C++ reflections. It's crazy. Yeah. Personally, I'm now most interested in C++, less as a language to write performance software in. Bro, I can't spell anything. Performance software in. Keep in mind, I am adjusting to this new keyboard as well. I think this is the first time I'm typing proper like sentences, paragraphs with this keyboard. But rather as a case study for how a programming language, for how a language can continue to evolve and add new features without majorly breaking backwards compatibility. Unfortunately, though, it is quite underfunded, if even just like not funded, as Bjarne has pointed out. But anyway, Did I press P there? All this activity is in preparation for a disruptive change, or, as we physicists call it, a phase transition. It's a nice term. If you keep heating water, it will eventually start boiling. Well, nice analogy, sorry. You are now in the position of a frog that must decide if it should continue swimming in increasingly hot water, or start looking for some alternatives. What the hell? I've heard this exact analogy used before. I don't know if it comes from this book, or if it's been, like, repeated many times within the C++ community. But yeah. That's one way to put it, I guess. But, like, you can also adapt as a programmer, you know, like, as a frog, you know, like, adapt to the heat. You can do that. So I don't love the analogy, but I am aware of it. One of the forces that are driving the big change is a multi-core revolution. The prevailing programming paradigm, object-oriented programming, doesn't buy you anything in the realm of concurrency and parallelism, and instead encourages dangerous and buggy design. I mean, this is very debatable and controversial. Data hiding, the basic premise of object orientation, when combined with sharing a mutation, becomes a recipe for data races. Again, like, it depends. The idea of combining a mutex with the idea it protects it is nice, but unfortunately logs don't compose, and log hiding makes dead logs more likely and harder to debug. Again, I haven't worked much with concurrency anyway, so I can't speak on that too much. Like, even in Rust, I'm yet to use mutex, or in C++, I'm yet to do any, like, multi-threading or concurrency, so I can't speak for that, but I'd be surprised if there aren't solutions. But even in the absence of concurrency, the growing complexity of software systems is testing the limits of scalability of the imperative paradigm. To put it simply, side effects are getting out of hand. Granted, functions that have side effects are often convenient and easy to write. Their functions can, in principle, be encoded in their names and in the comments. A function called setPassword or write_file is obviously mutating some state and generating side effects, and we are used to dealing with that. It's only when we start composing functions that have side effects on top of other functions that have side effects and so on that things start getting hairy. It's not that side effects are inherently bad, it's the fact that they are hidden from view that makes them impossible to manage at larger scales. Yeah. Well said. Side effects on scale, and imperative programming is all about side effects. Sure? Yeah, sure. I mean, imperative programming is all about, you know, do what I say, like you're using imperative language, you know, I mean, in contrast with declarative languages, where it's more like, do what I say, not what I do. But whatever. I mean, like, the line is so blurred anyway. I've already thought about making, like, a blog post about that. How the line between imperative and declarative is very practically non-existent. Changes in hardware and the growing complexity of software are forcing us to rethink the foundations of programming. The foundations of programming, yeah. Just like the builders of Europe's great Gothic cathedrals, we've been honing our craft to the limits of material and structure. There is an unfinished Gothic cathedral in Beauvais, France, that stands witness to this deeply human struggle with limitations. It was intended to beat all previous records of height lightness, but it suffers a series of collapses. Ad hoc measures like iron rods and wooden support keep it from disintegrating. But obviously, a lot of things went wrong. From a modern perspective, it's a miracle that so many Gothic structures had been successfully completed without the help of modern material science, computer modeling, finite element analysis, and general math and physics. Yeah, is it a miracle? Or is there something more interesting there? I hope future generations will be as admiring of the programming skills we've been displaying in building complex operating systems, web servers, and the internet infrastructure. And frankly, they should, because we've done all this based on very flimsy theoretical foundations. We have to fix those foundations if we want to move forward. Yeah. So it's like, you can get quite far on flimsy foundations, but at some point, it just becomes too much, and you need to revisit those. It's why, although I've started a lot of projects, I very rarely finish them, just because the base I started with them just becomes so fragile, or like was so fragile, and like the cracks start to show. And that's also why I tend to do a lot of refactoring. Like, yes, like, it means I'm delaying myself to the result, right? but at least I know that as I do it, I'm developing stronger and more robust code, and hopefully, well, assuming I'm still motivated to work on the project, which if it is important, I should be, I will go on to have, well, be able to go further with a lot less pain. And then what I learn from doing that, from those refactoring sessions, can be applied to future sessions. But then to do that, really, I should also be consolidating this knowledge somewhere. And this is why, we can share these foundations. But yeah, I mean, literally what he says there. Part 1. Right. Let's go. Category, the essence of composition. A category is an embarrassingly simple concept. A category consists of objects and arrows that go between them. Okay, so that was my understanding. That's why categories are so easy to represent pictorially. Pictorially? Yeah? An object can be drawn as a circle or a point, and an arrow is an arrow. Yeah, they aren't always called these, but yeah. Just for variety, I will occasionally draw objects as piggies and arrows as fireworks. Okay? But the essence of a category is composition. Or if you prefer, the essence of composition is a category. Arrows compose, so if you have an arrow from object A to object B, and another arrow from object B to object C, then there must be an arrow, the composition, that goes from A to C. Right, and this is, I guess, associativity laws, right? Sounds like associativity, associativity. Right. So category consists of objects and arrows. Okay. I don't like how it opens this this view here. Like, I don't want to do that. I just want to hide it as I go. So a category consists of objects and arrows that go between them. That's a core definition there. So arrows as functions. Okay, so those are fireworks, I see. Is this already too much abstract nonsense? For that phrase, abstract nonsense. Do not despair. Let's talk concretes. Yeah, and that's why I think that having it in the context of programming is very useful. Think of arrows, which are also called morphisms, as functions. You have a function f that takes an argument of type A and returns a b. You have another function g that takes a b and returns a c. Yeah, and then if I call f whatever. So let me highlight this as well. That's an important definition. In a category, if there is an arrow from A to B and an arrow from B to C, then there must be from A to C. Yeah, that is their composition. This diagram is not a full category because it's missing identity morphisms. I see. Yeah, like function composition, I guess. F of g of x equals f of g of x. So this is not a full category because it's missing identity morphisms. Right. You can compose them by passing the result of f to g. You just have to define a new function that takes an a and returns a c. In math, such a composition is denoted by a small circle. Notice the right to left order composition. For some people this is confusing. You may be familiar with the pipe notation in Unix, as in, or the chevron in F sharp, which goes from both left to right, which both go from left to right. But in mathematics and in Haskell, functions compose right to left. There should be a comma there. But in mathematics and Haskell, functions compose right to left. It helps if you read g of f as g after f. Sure? So do g after f, right? Yeah, I guess that's quite useful. Highlight that. Piping. Yeah, piping on Unix. I find it confusing because I also try to think about it from a functional standpoint. So it being the opposite is a bit confusing. But it makes sense or whatever. Yeah, the grammar. I'm trying to think. This is like latex on a GitHub repository, right? So like if I find like grammar mistakes, I could fix them, but like the thing is grammar isn't like universally agreed upon, so I don't know how far I get with that. I'll probably just like reserve it for like typos and things. And even then, like it's gonna be his own words, right? So changing too much is probably not even a good idea anyway. Let's make this even more explicit by writing some C code. We have one function f that takes an argument of type A and returns a value of type B. So bf takes an A, returns a B. Yeah, but I mean fucking C syntax is not good for this. C, G, B, B, their composition is... Yeah, so f returns G of f of A. Here again you see right to left composition, this time in C. At which I can tell you that there is a template in the C++ standard library that takes two functions and returns their composition, but there isn't one. So let's try some Haskell for a change. Is that still true? I mean, like, you probably could write a compose function, right? But I don't know, like, how far you can get with C++ generics and like type checking and all that. Yeah, so here's Haskell. So you get F, A to B, similarly B to C, then just G to F. I mean, Haskell is, like, honestly, Haskell is just such a nice language. The lack of mutability does frustrate me, and there are some other issues as well, but, like, just, like the core, like, syntax of, like, this, it's really appealing. It's just so terse, you know? Once you see how simple things are in Haskell, the inability to express straightforward functional concepts in C++ is a little embarrassing. In fact, Haskell will let you use Unicode characters, so you can write composition as... You can. You can even use Unicode double colons and arrows. Seriously? Is that standard? Double colons a Unicode character? I didn't know that. That's crazy. I mean, like, it's unnecessary, but it's cool. So here's the first Haskell lesson. Double colon means has a type of. A function type is created by inserting an arrow between two types. Yeah. Okay. Yeah, embarrassing is one way to put it, I guess. I mean, a lot of languages don't have this, so. I mean, Rust doesn't. There are two extremely important properties that the composition in any category must satisfy. Composition is associative. Yeah. If you have three morphisms, F, G, and H, that can be composed. That is, their objects match end to end. You don't need parentheses to compose them. In math notation, this is expressed as this. Okay. In pseudo Haskell, yeah. I said pseudo because good quality is not defined for functions. Yeah. I wonder if they could be. Associativity is pretty obvious when dealing with functions, but it may not be as obvious in other categories. Sure. For every object A, there's an arrow which is, sorry, what are these? Okay, no, so, sorry, I could these just skip this header. There are two extremely important properties that the composition in any category must satisfy. So one is associativity, okay. I am also aware of these from before. Okay, and two, for every object A, there's an arrow which is a unit of composition. This arrow loops from the object to itself, being a unit of composition. Being a unit of composition means that when composed with any arrow that either starts at A or ends at A, respectively, it gives back the same arrow. The unit arrow for object A is called ID, the identity of on A. In math notation, if F goes from A to B, then F of identity A equals F, and the identity B of F equals F. Dude, my body is such an op. Like, it does everything it can to stop me from speaking clearly. Like, giving me, like, making me gassy. So what, like, the front of my hair is fine. Like, if anything, it's like a miracle that is sticking up. But, like, what's going on at the back, man? Like, genuinely, dude. Like, at this point, it's either I grow my hair really long, so that this is, like, less of an issue, or I just shave my head. Yeah, the issue with the long root is that, like, that's a whole hassle in of itself. I mean, my hair's quite thin as well, and thin long hair does not look good. You want like long, like flowing, thick hair, but oh well. Hair transplant stream soon. Yeah, there's an arrow which is a unit of composition. This arrow lives for himself. Yeah, so highlight that. So, hold on. Yeah. So f is a morphism, but we're focusing on the object A. So if A has a morphism, or a function, whatever, that goes from itself to itself, then if I do f of identity A, then since it doesn't change itself, then applying f to that function just does nothing, right? It's just f. It's like f acts on A as well, but like if A just returns A, or like if the function just goes from A to A, then nothing changes there, right? And same with B. If I compose that with f, then I'm saying that just apply f basically. So when dealing with functions, the identity arrow is implemented as the identity function that just returns back its argument. The implementation is the same for every type, which means the function is universally polymorphic. What does polymorphic actually mean? Like, I always forget the definition to the point where I should probably just write it down. Having or taking many different forms, right. Meaning having or taking many forms. Lit poly equals many. Morphic equals like form, like forms, let's say. So many forms. In C++, we can define it as a template. So I have a template class T, which returns T, ID, T, return X, yeah. Of course, in C++, nothing is that simple because you'd have to take into account not only what you're passing in, but also how, that is by value, by reference, by cross-reference, by move, and so on. Yep. In Haskell, the identity function is part of a certain library called prelude. Here's a quotient definition. Yeah. And like, you may think this is useless, but it's, I guess it's more for like documentation purposes. Like if I have, like if I, like think in traits and type classes, right? If I want to implement a feature for something, you know, I may want to reuse the identity function to say that, yeah, like this function here is just implemented as the identity. That's probably the best way to think about it. At least that I have come across so far. Yeah. Yeah. I mean, like, this could have so many things. Like even like in Rust, for instance. Like, this would probably return a copy of the original. Right? So like for it to truly be the identity, it would need to return a reference to itself and take a reference as well to the object. So, you know, it's quite interesting because like it shows that math doesn't take, you know, like the actual computer science into account, and that's really important to think about. Yeah. Generally speaking, this exposes how maths doesn't take into account the computer in computer science, and can create, whoops. Okay, fine. Is it Control Y to undo? I don't know. To redo, I mean. And is what I imagine the main source of friction is in implementing these ideas. Because math is inherently abstract, but for computers you need like a concrete implementation. As you can see, polymorphic functions in Haskell are a piece of cake. In the declaration, you just replace a type with a type variable. Here's a trick. Hold on. Yeah. Here's a trick. Names of concrete types always start with a capital letter. Names of type variables start with a lowercase letter. So here, A stands for all types. Haskell function definitions consist of the name of the function followed by formula parameters, and here's just one x. The body of the function follows the equal sign. The sense is often shocking to newcomers, but you quickly see that it makes perfect sense. Function definition, function rule, blah blah blah. No combination arguments, which can be a bit confusing, but I mean, ultimately it's fine. The body of a function is always an expression. There are no statements in functions. The result of a function is this expression. Here, just x. Yeah. Yeah, okay. Why would anyone bother with the identity function? A function that does nothing. Then again, why do we bother with the number 0? 0 is a symbol for nothing. Yes. So, if I understand correctly... Ooh, okay, no. Like, say I have the category of numbers, right? Let's say integers. Of positive and negative integers. The identity function, first of all, would be adding 0. I think. Or something along those lines. Yeah, but like then, I don't think the category is even numbers. I think it's addition. Like the object is... Yeah, like the category would be addition, I think. The category would be addition. And then the object would be like integers, for instance. So then we have addition for integers. And then the identity would be plus 0. And there's something else that's called... I can't remember what it's called, but that would be 0, basically. And then for multiplication, that would be 1, because timesing anything by 1 would be the same, right? 0 is a symbol for nothing. Ancient Romans had a number system without a 0, and they were able to build excellent roads and aqueducts, some of which survive to this day. What is an aqueduct? Like a river type thing? Yeah, using gravity. Ah, okay. Interesting. So it's meaning a channel to carry water from between locations via gravity. Neutral values like 0 or ID are extremely useful when working with symbolic variables. That's why Romans were not very good at algebra, whereas the Arabs and the Persians, who were familiar with the concept of 0, were. So the identity function, really, they would be with algebra. Well, yeah, I mean, I guess algebra is literally an Arab, or like an Arabic descending word. You know, algebra. Yeah. I do want to look more to the history of that, really, like the origins of 0 in algebra. It's quite interesting. So the identity function becomes very handy as an argument to, or a return from, a higher order function. Yeah, let me just add that to my thing as well. The origin of algebra in Arabia/Persia, and the adoption of the number 0. A nothing number. To summarize, a category consists of objects and arrows, morphisms. Arrows can be composed, and composition is associative. Every object has an identity arrow that serves as a unit under composition. Okay. Composition is the essence of programming. Functional programmers have a peculiar way of approaching problems. They start by asking very Zen-like questions. For instance, when designing an interactive program, they would ask, what is interaction? When implementing a complex game of life, they'd probably ponder about the meaning of life. Literally, yeah. Yeah, but like literally. In this spirit, I'm going to ask, what is programming? At the most basic level, programming is about telling the computer what to do. Yep. Yeah, I mean, I would define it as taking, as defining a list of instructions for a device to carry out, right? To be computed. Take the contents of memory at just x and add it to the contents of the registry EAX. But even when we program in assembly, the instructions we give the computer are an expression of something more meaningful. We're solving a non-trivial problem. If it were trivial, we wouldn't need the help of the computer. And how do we solve problems? We decompose bigger problems into smaller problems. If the smaller problems are still too big, we decompose them further, and so on. Finally, we write code that solves all of the small problems, and then comes the essence of programming. We compose these pieces of code to get solutions to larger problems. Right, decomposition wouldn't make sense if we weren't able to put the pieces back together. Yeah, I mean, that's a very functional way of looking at it for sure. A lot of programmers like kind of reject this. They don't like the idea of starting with the abstraction and then breaking it down. But if you know what you're doing, it's very powerful. Yeah. This process of hierarchical decomposition and recomposition is not imposed on us by computers, it reflects limitations of the human mind. Our brains can only deal with a small number of concepts at a time, yeah. One of the most cited papers in psychology, the magical number, 7 plus or minus 2, postulated that we can only keep 7 plus or 2 chunks, plus or minus 2 chunks of information in our minds. Yep, the details of our understanding of the human short-term memory might be changing, but we know that for sure that it's limited, yeah. The bottom line is that we are unable to deal with the soup of objects or the spaghetti of code. We need structure, not because well-structured programs are pleasant to look at, but because otherwise our brains cannot process them efficiently. We often describe some piece of code as elegant or beautiful, but what we really mean is that it's easy to process by our limited human minds. Elegant code creates chunks that are just the right size and kind of just the right number for our mental digestive system to assimilate them. Yeah, I'm well familiar with that. So what are the right chunks for the composition of programs? Their surface area has to increase slower than their volume. I like this anal algae because of the intuition that the surface area of a geometric object grows with a square of its size. Their surface area has to increase slower than their volume. What does that mean? The surface area is the information we need in order to compose chunks. The volume is the information we need in order to implement them. The idea is that once a chunk is implemented, we can forget about the details of its implementation and concentrate on how it interacts with other chunks. In OOP, the surface is a class declaration of the object or its abstract interface. In functional programming, it's a declaration of a function. I'm simplifying things a bit, but that's just a bit. Right. Linking to Wikipedia is devious in your references, because that's the first thing people would look up. Yeah, I had a similar idea recently, which was basically, right now, we hold on to a separation of interface and implementation, but I would argue that we should really just cut it completely, separate them. I think that interface should be completely separate from implementation, because otherwise what happens is that we design our interface around our implementation, and have, for some reason, we have the implementation leak through. Like, if I define a struct, right, called RGB, and has an RG and B fields, it has RG and B fields, and let's say that their implementation is uint8, right, a uint8 unsigned 8-bit integer, and then, that's the implementation. But then for the interface, I also expose them as uint8s, which means if I ever change the interface to, for example, use a bit array, or a bit vector, whatever you want to call it, or maybe I want to use a uint 16 instead, so that they fit into a 64, or even if I want to add a new alpha channel, right, that changes the implementation while also changing the interface, which is not what you want. Or likewise, if I want to improve the interface, I typically also have to change the implementation, because I have situations where the interface is the implementation. But what you want is a language where that forces you to separate them, because obviously you don't have to do that. You can wrap all the fields in functions instead. You have get red, get blue, get green, and then set red, set gray, set blue, set green, and then have a general integer type, right? Or use floats even, use doubles, and then convert the uint8 to a double when you fetch it, or have different things that you can extract it as. You can have these, but it's so tedious. And people talk on Java for being very boilerplatey in that sense, but what Java does is the right idea. It's just that the language doesn't have the facilities to really make that not what's the word? Tedious. And that's because Java is built on the C++ foundations and C foundations. What you want is a language that separates them. C# has properties, which is good, but the issue is the properties can also still... Oh, sorry, the issue is that you still have variables that are directly in the class that are exposed to the user. So, yeah, it's interesting there. Really, I want to find a way to make them completely separate without being tedious. Because like not many languages even have like getters and setters. It's still a fairly niche feature for a language to implement. Usually we just like manually define our functions, right? Get this, set this. But it'd be like, why wouldn't you have that? Sorry, no. When you do have that, you have a conflict of interest, because then you go from just variables and functions to variables, properties, and functions, right? And that has overlap, and then like it's not clear when you should use one over the other. The answer is probably just have properties be public and have variables and implementation details be purely internal. And I wonder how we can achieve that. Category theory is extreme in the sense that it actively discourages us from looking inside the objects. Does it? Okay. See, I didn't know that. An object in category theory is an abstract, nebulous entity. Holy vocabulary, dude. Nebulous. Vague, unclear, or lacking a definite form. Okay. Lacking a definite form. Bro, I can't spell, bro. What the hell? Meaning. I swear I make less typos while writing code, so I don't know what's going on with me right now. All you can ever know about it is how it relates to other objects, how it connects to them using arrows. This is how internet search engines rank websites by analyzing incoming and outgoing links, except when they cheat. In OOP, an idealized object is only visible through its abstract interface. Pure surface, no volume, with methods playing the role of arrows. The moment you have to dig into the implementation of the object in order to understand how to compose it with other objects, you've lost the advantages of your programming paradigm. Wow. Okay, I'm glad that I came to this conclusion myself. Because, yeah, it gives you more confidence, and it's weird that other languages don't really do this. Even like to my understanding, like Haskell won't motivate you to do this either. Like if and I can use an example to back up my claim here. If I look at my project over here, GitHub, go to my repos. Let's look at my Haskell projects, of which I actually have quite a few, right? I have 12, which is more than 0. And look at my image to ASCII. Look at the app. Like, this is a case where like I need to get low level to an extent. You can't have a programming language that like purely uses abstract types. You need to get like low level. I want to have a uint 8, or I want to have a bit array at some point. So here you see I have an instance of a strawberry pixel, where size of is 4, alignment is word 8, I guess, and then I have these functions here. Like here I have an image, which is my pixels, which is an x vector of pixel, and then I have my width and my height. But like, notice how these aren't like interfaces. Like this is the actual implementation of the type. Maybe the compiler will change it a bit, but like ultimately I can specify more or less how I want it to be represented in memory. And maybe I can write an interface around it, but like Haskell doesn't really force me to. Like by default, like you get what you see, which isn't good. Like the implementation should not be what the interface is, but here it is. And also like like dude, the code is so not nice to write here. Like Haskell is like generally has some cool things about it, but this is just so annoying. So much of this was really unpleasant to write. Yeah. So very, good start. Already the book is, related to my thinking. Okay. Yeah, so I've been having the same thoughts. Many languages make it too easy to have the, make it a default to have the implementation of a struct or class, of a type, of a user-defined type. Actually, just in general, of a type, also the interface. For example, I should be forbidden from making class members, class variables, public. Instead, we could rely on C# style properties with getters and setters, so that the interface can remain the same while the implementation changes, and vice versa. Yeah. Let's do vice versa. Bro, how do I redo? Control Y, control for Z. Like, if I can control Z to undo, like surely I can, redo it, bro. I have no option. Undo. Oh, okay. What did I press? Control delete. I don't know. But yeah. Oh yeah. I did. For some reason, control delete deletes it. But it doesn't even, it's like delete the entire line. Whatever, dude. Okay. Challenges. Implement as best as you can the identity function in your favorite language, or the second favorite if your favorite language happens to be Haskell. Okay. Implement the composition function in your favorite language. Should I do this? I mean, I don't really need to, because I already know this stuff, but it could be fun. The thing is, then I need to open a whole project and stuff, and I can't be arsed, dude. Write a program that tries to test that your composition function respects an entity. Is the World Wide Web a category in any sense? Are links morphisms? Yeah, interesting. Are links morphisms? They take you from one page to another, but they're kind of like global morphisms. Like, it says take any A, or take any object, or take any object, and then transform it to this object. Yeah. It's faced with a category with people as objects and friendships as morphisms. I don't know. Can I think about it that way? My people as objects, they have an identity, right? They are themselves. And then the friendships are they morphisms? Because the morphism would imply that it transforms A to B, right? Like it's all connection. Like it's a morphism. It morphs it. So like if my friendship to Jake creates a morphism from me, Kojo, to Jake, let's say, that would imply that I can transform Kojo to Jake. But maybe it depends how you look at it. Like maybe if I have a friendship with Jake, it means that if you can follow that friendship to reach Jake, and then it's like a connection thing. But right, sorry, it says Facebook. Yeah, so friendships would lead you to other profiles. I don't know. When it's a directed graphic category, when it also has arrows pointing to itself, I guess. Okay, so that's the start. So before we go any further, let me go ahead and consolidate these notes. So, Chapter 1. Category, the essence of composition. So category, the essence of composition. Yeah. Typo, Right, I have no spell check on this, so if I make a typo, that's going to be pretty bad. Okay. So a category consists of objects and arrows. Right. So a category consists of objects, or a category is objects and arrows, aka morphisms. If I have an arrow from A to C and another arrow from B to C, then the composition goes okay. And then you got composition. So if I have for objects A, B, C, A to B. Does that show as an arrow? What? Control E. Yeah. If I have, if there exists some latex here, I think it's out this. Yeah, if I have A to B and B to C, then there exists the composition of both, hold on, if there exists the morphisms, yeah, then there exists the composition of both morphisms A to C. That's like that kind of like formal definition, right? My font is geeking here. What is a default font for Obsidian? Let me see if I can sort this out real quick. Put it there. Like, what's it overriding? What the hell? This is always very difficult to do when I'm recording. Like, I don't know why, but like OBS really. I mean, I guess it's not surprising, but like for some reason, like this in particular is heavily affected. Right, so looking for fonts here. No? Yeah, there. Okay. Font. Family. It's going to take a second to show. Right. So there's a variable called font text. Here we got JetBrains Mono, yeah. If I click on font default, sorry, it should take me to it in its own time. I feel like it didn't take me there though. It says it's JetBrains Mono, but like, where is it defined? No, if I click it, it just doesn't even take me to it, which is really annoying. Obsidian default font. Enter. Could be Sego. Segoi. Segoi. Okay, let's try. Oh, I should probably open my. Add this to my thing actually. Obsidian config, right? I believe it's in. I believe it's in .config/obsidian. Ooh, but actually, it might not be. It might just be in my Vault instead. I think it is. If I go to documents, home/documents/brainlet. Bro, these typos are crazy. And then go into Obsidian. No. Yes? Yeah, Obsidian. Yeah, and then snippets. Right. So go to styles CSS. Right. So if I change this to Segoi, hold on, Sego UI. It's not how you spell it, is it? Sego. What? Sego. Okay, yeah. I think in Japanese for some reason. What? Dude, undo. Jesus Christ. Sego UI. Yeah, definitely need to adjust with this keyboard. Right. Now, I assume I won't change it immediately. Probably need to like refresh or something. Try to close this. And potentially fail. There you go. Yeah. So can I... editor? It's here somewhere. Plugins? No. Could probably just do it here instead, actually, but... Yeah. Instead of doing it in a snippets file, it's probably like just more safe. But what's the default? I don't know. Tell you what, let me delete these. Save that. Okay, that changed it. Now notice how here those quite small, like the arrow is now a ligature. So first of all, interface font. I want JetBrains. JetBrains nerd font. Doesn't matter. It wouldn't use nerd things anyway, but I guess just for safety. Okay, so that does that. It's not affecting these though, which is weird. Maybe because I need to relaunch, but it shouldn't be. Then for text font, like what is it? I don't know. Monospace font will go with again JetBrains, obviously. And then what's this font? Let's inspect. Take this. Okay. It's this whole string. UI sans serif, Apple system, but my system font, Sego UI. So it's probably Sego UI, but I don't have Sego UI. Right? I don't know. It's kind of weird. Let me add it back then. But paste this. Yeah, I'm gonna try that instead. Maybe. Take it back. Yeah. So let's see if I can like reverse engineer this intent here. First of all, there's UI sans serif. If I remove all of these, still the same font. Okay. If I remove Sego UI, still the same. Is it Roboto? Roboto. I would imagine it is. Because if I remove that, no, still fine. If I just remove all of these, first of all, actually, just that, yeah, then it's default font. Okay. So let's keep trying then. It's that one. Nope. Bro, what's N1? N1. Is it Inter? Yes. So okay, yeah. So it was Inter the whole time. Okay. So I'll just remove this then. Hold on. VS. Yeah. Okay. Delete that. Nice. Okay, so we'll use Inter, which is their own font, purely because it has the ligatures, which is pretty good, and then we'll keep the other ones. Otherwise, okay, we'll add styles or CSS, and commit change font to, or change text font to Inter, since it has the nice ligatures. Push that. Right. Anyway, so composition, yeah. Good, now it looks proper. Go back to the PDF here. Outsource functions, yeah. It's called morphisms. Doesn't even matter about that, to be honest. That is a composition. It helps if you read G of F as G after F, yeah. So, N, what is this? Ours is functions. Just copy that. If I remove that, is it still readable? Like have like 2 spaces, but it doesn't even render the spaces anyway, so whatever. The issue is like if I have like 1 and then like 2 category as like in the title, it just looks weird. So I'll put a dash. Anyway, so ours is functions. Yeah. Since the maths notation for function composition, actually just like in general, for composition is read right to left. It can help to read G of F. So G, I think it's of, even just F, as G after F, or as G after F. solve. What is it then? I can't actually remember. G of G. I don't know. Latex function composition. Would be good to have like a cheat sheet for latex, honestly. Circ, that's right. Yeah. Okay, let me create a new cheat sheet here. Call it latex. Yeah, go ahead and open latex here. Let's create a table. A table though? Do I want a table? They're kind of a pain to like. Well, I should do, yeah. Which is that like I don't get the formatting automatically. How does it even work? So I have symbol. No. Results. What? Yeah. Symbol. Code. And then use. Like meaning. Stuff like that, and then just create that. Okay, it's kind of meant to make a table here. I don't know what I'm missing. Do I need a cheat sheet for tables? Like this? No, that's YAML. What? Insert table. Alright, okay. Alright. It's like this. Yeah, okay, there you go. So for example, circ, right? / circ. I guess this like example could be useful. Yeah, so we've got circ, code, just type it out, I guess, same thing. Meaning, composition of, example, F, a G, circ F. These are just to help like searchability more than anything. Okay. Load file, yeah. Go back. Nope. Go back. Okay. Anyway. Okay, so it's associative, yeah. There's properties of 1.2 called what? Properties of composition. So I'll just view that, paste. There are 2 key properties of what? Of composition for a category to satisfy. 1, composition is associative. 2, every category has every object or category. Every object. Every object must have an identity morphism. Literally, ID. How do you write this, by the way? Like in bold? If I inspect this, which can be a lot faster for some reason. Yeah, if I inspect this, can I see the latex? Or is it just rendered already? Yeah, no, definitely not. Or is it? What? What? It's not even like latex. It's just put in there like directly. It's kind of funky. Or I guess that's how latex works. I can also look at the latex version of this. Yeah, on this. But this is unofficial, right? Where's like the official one? That's PDF. Yeah, this is more stars. So looking for source, content, 1.2, code. Oh, what? Okay. Definitely not the right place. What? Types and functions. One 0.0? Like what? That's the preface. Is this chapter 1? Oh yeah, okay, yeah. So like that's like the whole like chapter. That's not code. I mean that's code, not latex. Don't mathify this block. F ensure math : A to B. Oh there, that's code, right? Yeah, here. So we go circle, circle, okay. New term identity. Cool, it's like a function, right? ID arrow A. Okay, so they have it defined. Right? Yeah. So I'm looking for ID arrow. Where is that defined? It'd be global, right? ID arrow. Man. What's reason? Is that language? Must be a language, yeah. Where would I find the definitions? They'd be here somewhere, right? Here's ID, defined as mathbf ID. Oh, here you go. Yeah, ID arrow. Okay, it's a function. It's mathbf ID with a subscript of A. Okay, so I don't know if I can define like the same template things, but I don't need to per se. But obviously it makes things more convenient. So it'd be math bold formats, ID, and then yeah. There you go, perfect. That simply returns itself. What's the language here? The morphism points to itself? Yeah. Probably the best way to think about it. Okay. So that's mathbf. So let me open the latex cheat sheet, add that as well. So we got mathbf B. Yeah, bold text or bold formatting. Is it actually bold format though? Mathbf latex. boldface. Okay. Boldface. Example, don't need one. Not really, but whatever. MathBF, ID of A, right? And then open that in the editor, just so I can do some formatting stuff here. Yeah. Nice. So that's how this actually, because this is renders it in monospace, it's actually aligned here when it's not here. It's pretty cool. Anyway, good to know. Go back. Yeah. Did I skip some definitions? I guess not. Oh, I also skipped the fucking preface, didn't I? Yeah, okay, that's why. Okay, I need to come back to that in a second. Polymorphic, meaning having, taking many forms. Yeah. The position is the... Okay, I don't like how it's covering that, like, indefinitely. Can I hide comments? Because like it's actually covering the thing. I can't see it. It's like a toggle comments or something. No, bro. This. Yeah. Okay. I think I need a better PDF editor if I want to continue with this. The implementation is the same for every type, which means this function is universally polymorphic. Yeah. So we say that polymorphic means literally many forms. For code, yeah, code that is able to accept different types. Essentially. Whatever. Yeah, also how. Generally speaking, this exposure of math doesn't take into account the computer in computer science, and what I imagine the main source of friction is implementing these ideas. Yeah. Put a separation there as well. Yeah. Just copy this and quote it. I think I just do quote like this, right? Yeah, new line, and then I mean, it works. Oh right, I can just do this. Oops. Yeah, same thing. In fact, these shouldn't even be separate lines. Hold on. Yeah, no, so that should be the same line, and that should be the same line. Okay, there we go. This does go to show that there may be limitations. Show that there are limitations, or well, that applying math to programming is not so straightforward, as math lives in the world of abstract, whereas computers have to be, which is useful for interfaces, well, yeah, for APIs, but but computers ultimately needs a concrete implementation. Yeah. Okay. Word here, aqueducts. And this is my notes. I have no qualms with just copying what I wrote. Aqueducts. Aqueducts. I do actually have a like a definition thing. I think I defined one like this. Aqueducts, and then I would copy that line here. Yeah. I guess I should actually then. Yeah, let me do that. Because they come up quite often. Boom, boom, boom. Yeah. Same thing there. It just has to like stand out a bit, you know. Not that important. The issue is just like not abusing it for things that aren't simply definitions. So a category, yeah, like this should really say a category is made up of. Oops. Yeah, a composition. States that, yeah, okay. Right, so I didn't get this. They're useful when working with symbolic variables. Symbolic variables. What does that mean? So I'll copy that as a question. So a wonder. Actually, first the quote. What does this? Yeah, what symbolic variables? I don't know if it needs to even be like in a wonder tag. Yeah, definitely not actually. That can be sorted out some other way. Yeah, not even like what are symbolic variables? Like self, I guess. Like that's like built in anyway. So, like yeah, I don't know. Any useful examples? I've seen some uses of Haskell's ID in its traits in its type class definitions. For example, with like the just, or like the maybe monad, I guess. Sorry, for monad in general, you have the pure function, right? Which is just pure of itself, kind of. So like, is that pure.id? Is that what happens, I think? Something like that? Let's see. Haskell monad definition. By the way, I'm thinking of disabling Vim thing, because like it's too sloppy, or like too choppy. Like it's well made, I'm sure, but like it just doesn't integrate into the compiler well enough. Sorry, into the browser well enough, and that's just it's just too annoying. You know, like it, because like when you to really reap the rewards of Vim mode, you need to be able to not touch the mouse ever, ideally, and that's just not really possible with a browser. like this that isn't built for it, because like there's just things that we're not that just are inherently problematic. So I don't know if I'll keep using it. Return is pure, yeah. But then what's pure? A is MA. I guess I can ask my assistant. What are some examples, real-world examples of where ID is useful in Haskell? Default arguments for higher functions. Maybe X, ID just X. What? From maybe either. Traversals optics. Function composition pipelines. ID for empty lists. I guess? Yeah? Well, no, yeah. I see that in terms of like, but the ID doesn't have to be an empty list. If con then F else ID. That's actually quite useful. That's pretty cool actually, yeah. If con then F else ID. Huh. For example, if con then F else ID. In Haskell, you could have yeah. I don't know how ID is highlighted there, but whatever. Okay. Right, let's go back up to the preface. And should I be like doing like point 1 and everything like that? Part 1, part 2 and all that? Probably not. Don't think it matters having part 1, part 2, part 3. But I will have a preface called preface. Yeah. So percolating. I got a definition. Percolating. Yeah. Category theory is kind of math that's particularly studied for minds of programmers. I calculate a measure with mobile engineers for purposes. Programmers by from a math category thinks about design industry software engineering architecture. Yeah. What the hell? Okay, I don't know how that got highlighted there. So let's highlight that, if you don't mind. There we go. Okay. Composition is at the very root of category theory. Okay. Is a part of the definition of the category itself. Right. So composition is a key concept in category theory, as it is part of what defines a category in of itself. Right? It is concurrency composable and sometimes virtually possible with other program paradigms. Yeah. Okay. Quote that. Oops. Is that link? No. Okay. And then my thoughts on that. Physics we made, amazing analysis of informal reasoning. Yeah. It needs to be formal standard. We don't need formal standards. We don't want the changes to be so I imagine it's more so that we have the formal standard. How is the most okay, right. Obviously, this is like the more tedious part of the process where I'm, you know, moving my notes over. But it's good as well because I get to revisit my ideas as well as I do it, which is quite nice. In lieu means instead of, right, or in place of. Here. Definition in lieu. Probably French, right? I've heard it a few times, but by the way, I won't copy every single definition I come across. It's just the ones that are particularly interesting. In lieu means instead of. In lieu of, instead of, or in place of. Yes, I use lowercase for this one, but uppercase for the other ones. That's because like this is like a definition. This is more like a synonym, right? So that's my convention. Feel free to argue against it. Okay, and then I will introduce it slowly and explain everything as I go. Yeah. I can also like filter out notes that I don't think are actually that worth keeping, but that should be fairly rare anyway because ideas are interesting regardless. Oh yeah, Shift J exists. I was thinking like surely there's like a way to like connect lines more easily. Yeah, Shift J literally just does it instantly. Okay. But since then, okay, can I if I do will that move it? No. So I scroll manually to make it match. But since I can't explain it to this on a scale, I will introduce it slowly and explain everything as I go. And I said this. This reader. So even if readers do already know Haskell, there is value in learning something that you already know, again from the foundations, as you might realize gaps in your knowledge, in your understanding rather, and or come to see things in a new, interesting light. Yeah. Seals has been recently evolving. Yeah, sure. At a frantic pace. Yeah. Whoops. There's a frog, an algae. It's a fact that they're hidden from word that it's impossible to like on larger scales. It's not side effects are inherently bad, it's the fact that they are hidden from view that makes it impossible to manage at larger scales. Right. Yeah. Side effects are undoubtedly useful. In fact, they are necessary for computer programs, no matter how much a language tries to wrap and hide them and pretend they are pure. They are, in fact, pure. Where the problem really arises is in how side effects can be hidden in composed functions. Right? Like, for example, crash is a very clear function name that tells me there is a side effect. But if I wrap this, if I use this in a, if I compose this, if I create a new function that makes use of crash, new function that makes use of it, called unwrap. In fact, crash is probably not a good example here. Let's do panic. Well, not even. Yeah, let's do crash. Then it is no longer clear that the function can crash unless I rename it to unwrap or crash. Haskell, for example, Haskell is an example. Haskell helps solve this problem by making I/O explicitly part of the unwraps type signature. Right. Okay. So there, I've expanded as well on my thoughts, which is good. Yeah, we have to fix these foundations if we want to move forward. Here. Yeah. Well, this highlights the importance of code maintainability. As code with weak foundations. Well, with okay, as code that isn't designed to be maintainable is bound to crash. Well, is bound to impede development down the line with all sorts of architectural errors, architectural issues. Yeah. Okay, and that's the end of that. Part 1 done, part 2 done, and noted on. And there you go, got all these notes. Whoops. Got all these notes. Quite a lot already, to be fair. Just from like the first 2 chapters, one of which was a preface. And yeah, so then the next step would be to make atomic notes from these. I'm not going to do that just yet because I'm still in the introduction. It makes more sense to make my notes after I have a stronger idea of what I'm talking about, and then I can use those. Because as my understanding of like categories and stuff improves, I'll be able to make better notes on them. So I can show that later as well. But what's next? Yeah, so I did 1.1 and 1.2, right? I did both. Yeah, and we're in the same chapter. So this is 1.3, and then you got challenges at the end. Wait, no, I read this. Sorry. Okay, for some reason I didn't take any notes on 1.3. No, I did here. Okay. Yeah, okay, so my bad. So I finished chapter 1 even already. Okay, so let's add some of these then. Excuse my incoherent speech. Yeah. Yeah. So we have a definition down here. Nebulous. Which means lacking a definite form. Or something which lacks something. That which lacks a definite form. Is that right? Yeah. That which lacks a definite or has a vague form. Vague. Okay. An idealized object is only visible through its abstract interface. Yeah, that's a quote. I could make a keybind for this, but I feel like it's not that important. Like, not that I'm crazy to type. Yeah, these notes, right? Copy that. Cool. And then challenges, nothing there. Okay. And then types and functions. All right, that should be very, very interesting. So I'm gonna stop there because I've been doing this for 2 hours already. And I do other things to do and get on with, but yeah, good start. So again, here are my notes now, and I can use these to create atomic notes. Tell you what, let's have a look for now and see if anything comes to mind. So I'm using algebra, which are actually no. The first thing actually is to create a cheat sheet here for vocabulary. Vocabulary or I'm trying to think. Should they be? Okay, how about this? I'm gonna create a folder and call it vocabulary. And then we'll have like English and stuff. I mean, I don't really want to do other languages per se. Like, could. The thing is, I'd like, what's supported in card titles? Like, can I have Japanese? I probably can, right? I mean, I guess I can just test it myself. So like, if I say I want to do I don't know, this word, is that fine? No, that's not fine. Is it not? No, it is fine. Okay, cool. So let's do okay, I think it's the same thing. Fuck? Okay, I don't know why I still think someone fucking Japanese keyboard there. Polymorphic. Yeah. So literally, okay, so yeah, for this one, let me just kind of copy that. Okay, let many forms. Code that is able to accept different types. Yeah, and I'll say like in programming. Okay. Probably move this as well then, right? Ad infinitum. You could argue that I don't need to have different like things for this, but whatever. To infinity or forevermore. Yeah. To infinity or forevermore. Often used in argumentation. Origin, Latin. Take this. Okay. What's he got? Percolating, spreading and growing gradually. That comes up later, right? No, I'm actually quite high up. Hold on. That's the first one. Okay. Let's create a unit here. Call it percolating. Spreading and growing gradually. Well, spreading or growing gradually. Even just gradually, yeah. To my synonyms, right? Okay. In lieu of. Meaning instead of or in place of. Right? Polymorphic aqueducts. A channel to carry water, blah blah. Is it from Rome? That doesn't matter, does it? Oops. Okay. Nebulous. I generally set up like some keybinds to make new cards from my view of him. That is another thing I need to do. That which lacks a definite form. Vague. Yeah. Okay, that was all those, I think. Then, okay. Yeah, it's weird how much we learn calculus and like algebra in university for computer science. Like I get it's useful obviously in like computer science things like I don't know cybersecurity and I guess optimization as well would be good there for like algorithms and stuff. But like for just like entering the job market as like a programmer, like you're a software engineer, not a cybersecurity expert, or like a compiler optimization engineer. Like you're a software engineer. And so like really they should prioritize that, but I don't know yet. That's like a pre-baked thought. Pre-baked? Half-baked? Composition is a key concept of category theory. I haven't explored that deeply into concurrency, but SIMD, yeah. Shows that we don't need to make a formal standard of communication to come. And like, I should note as well, like these notes in my thing, they don't have to contribute to my atomic notes, at least not yet. Like they also just like exist as my general thoughts around the material. So if I ever want to refer to this, I can have a look at that. It's just I don't need to add a formal standard of communication to come up with new ideas and make breakthroughs. I imagine it's more so that having the formal standard is particularly useful for them to share with others. Right. So like this one's interesting. So I can make an atom here, and then go hunt for it. Yeah. So although a formal standard of communication, e.g. mathematics, e.g. the language of mathematics, is useful, is, well, yeah, very useful, undoubtedly useful for the sharing and dissemination of knowledge, of our knowledge and understandings. It is not a necessity for technological, for progress to be made in a field. Of a strong, it can help build. Well, it is. What's the word? Instrumental in building in constructing a strong foundation for which new ideas can be I guess built from, or from which new ideas can be. Yeah, built from, why not? But the same ideas can be built from weaker informal foundations too. That of course is not to say that we, yeah, okay, no. Therefore, we should recognize the importance of formal communication standards, while not restricting those who wish to venture beyond what we have defined, or what we have formally defined, because there is no telling what might be discovered. Sources link to this category theory for programmers. What's this one? The same, is it? Is it? It's like a link of itself? That's weird. Why would I link to itself like that? I don't understand. Anyway, can I go through programmers? Specifically, hashtag this thing. Unfortunately, it doesn't show me the content, but I do need that. So I'll save this, open it here. Whoops. Open it here. And then here I can edit with that and find what I was talking about. Formal, there. Cool. And then give it a title. This is formal communication standards are incredibly useful, but not essential for discovery or for research. Say research. I always do that, dude. Formal communication standards are useful for research, but useful for new research. What? Are useful for leading to new discoveries, but not essential. Okay, and that'll be mathematics. Is mathematics? I mean, I reference mathematics, and I guess like communication, and like systems almost. Okay, I mean very vague categories there, but whatever. And nothing been deleted, so that's fine. Okay. Even if you lose your already know Haskell, there's a value in knowing something from functions that you already know, as you might cover some gaps in knowledge. Yeah. I don't know why that's copied twice. Oh right, because I meant to delete this one. Okay. Yeah. Oh yeah, just automatically. There is value in relearning something. In relearning something that you are fairly confident. Well, yeah, in relearning something, regardless of your confidence level, as you never truly know what gaps have been left. Well, what gaps may show in your knowledge and understanding, or knowledge / understanding, and you may also realize things you already knew, but in a new, interesting light that could have useful implications. What? Yeah, no, just that. Okay, I don't know how that deletes the sources, but must be a typo somewhere. Dude, what is that keybind that does that? Yeah. And this comes from, again, category theory for programmers. And just go ahead and add the hashtag thingy there. Learning. Yeah. Okay. Title. Relearning is valuable no matter. Relearning can have value no matter your confidence level. Topics, education. Yep. Dude, my hair is like it just pisses me off. Like this has been here for my entire life, man. Please. Interviews during your hair scale. Like I'm hoping that when it gets longer, like the weight of the hair will just drag itself down. But I think part of it is that because my hair is so thin, like it is more prone to just sticking up randomly, like in random places, just because like it's light. I don't know. Personally, I'm not much in C++ lessons language. Yeah. Side effects are undoubtedly useful. In fact, they are necessary for computer programs, no matter how much a language has to wrap and hide them. Hold on. C++ is like it's an interesting case study. Yeah. Side effects are undoubtedly useful. In fact, they are necessary for computer programs, no matter how much a language has to wrap them. I'm gonna not do that note yet because I'm not so sure on that. Ugh. Yeah, maintainability. Categories made up of objects and arrows. Right, so now here's like the meaty stuff of category theory. So categories made up of objects and arrows, also known as morphisms. Right? But like, what are objects and what are arrows? I don't know yet. So I don't want to make this a note yet. What I can say confidently for now, though, is that every object in a category must have an identity. So, in a category, in category theory, every object in a category must have a morphism. I prefer the term morphism because like an arrow is like a pictorial way of thinking about it, you know, like diagram. Whereas I prefer to think about like what's actually happening. It's a morphism, you know, it's morphing, it's changing form, kind of. Must have a morphism from itself to itself. This is known as the identity morphism, or well, just the identity. Math yef ID. Represented by mathf A for an object A. Okay. Diagram, category theory diagram. Holy moly. How does spelling like ability just deteriorate so massively there? The thing is, like, is it always there, or is it more like implicitly recognized? Like here, like this shows the composition, right? But like, do you always have to include the identity or not? I assume no. But yeah, I mean, it's pretty. Should be pretty straightforward, right? A points to itself, B points to itself, and then you have this as well. So this is the useful diagram that also shows composition. And although I don't want to show composition, I want to focus on just this part, which I guess I can by just screenshotting this, right? I do need to get myself a better screenshotting tool, by the way. I do have one, but I just had issues with it on my dual monitor setup. So once I can figure that out, I should be good to go. Can I insert images here? Not quite. Okay. Let's use this for now. Whoops. Give it a name as well. Category theory identity diagram. Yeah. .png. Cool. So this is known as the identity, which I'll wrap in bold. Sources, yeah, category theory. Category. It's not fuzzy search. God, I can't spell it. Category theory for programmers. At identity. Yeah. Okay. Topics, category theory. That's not a thing apparently. Okay. Category theory. So each object in a category must have an identity morphism. Would that be called an isomorphism? Maybe? Category theory, isomorphism. No, but two categories can be isomorphic, that's right. Which means... yeah, so something with functors, okay. Functors are also morphisms, by the way. It gets very interesting, I'll say. So I'm very excited to go deeper into this. If you know, then you know already. But if you don't know, and you're watching this video, then be excited to look into more category theory. Okay. There's this as well. Massive in the world of abstracts, use APIs or computers as we need a concrete implementation. Which is like another reason why you should separate the interface from the implementation. So I kind of draw off both of these thoughts here to finish off. So I'll just go here. Humans, we like to think of categories, we like to categorize both the concrete and abstract in abstract way. No, that's not right. We tend to think abstractly, which applies to how we architecture programs, software as well. But unlike maths, which is purely abstract, computers require concrete implementation. Therefore, it is likely a good idea to design a language such that types separate their implementation from their interface. This means that if I define a struct, so I have a C struct here, struct RGB. I don't know if that's valid C. RGB. Actually, I'll do Rust, just for syntax convenience. So if I have RGB be red U8, RG and blue, then I shouldn't interface with the colors through these variables directly. Instead, I should need to interface through some kind of something like C# properties that allows me to change the implementation of how the colors are stored without changing how the user of the RGB type would access the colors, i.e. RGB.red should remain the interface regardless of how I change the internals. Yeah, and that's inspired. So let me open this here. I guess two things here I can link to. So we have yeah, so this part, this does go to show that part, and then also, I mean, same note, but just like so I can reference, because like, I mean, ultimately I assume this like this one file is going to be massive with all my notes, so it's not enough to just like link to the note and say find it somewhere. I've been there. Okay. Good. Then just go ahead and title this. So a types interface and implementation should be kept separate. Topics, this goes in software architecture, it goes in programming language design, and it goes in category theory? Well, not so much. I guess like abstraction. Yeah, I mean, again, like these topics are very vague. I could probably do like an overhaul at some point, but anyway, yeah, there you go. So then I managed to create a few notes there, and now you can see here, this will be more, I don't know, elaborate? Okay, they aren't cross-linking yet. Your atoms should be cross-linking to each other, ideally. So I'll see about that as well, but for now I didn't think of anything that came up while I was writing that. But we'll see if that changes. See if I can find it somewhere. I can't do like a search, which is kind of annoying. I think purple are my sources. I've got a bunch of sources that just don't link into anything right now, which is not ideal either. So I need to go through these at some point. These shouldn't be here. I need to filter those out. But looking for one that's like linked to like a few. I don't know, is it even here? I don't know, it doesn't matter, it's too messy anyway. I wish I could sort these as well by date, like really easily. But for whatever reason I can't. So that's an Obsidian thing. If I go Control O to go back, yeah, I can't. I gotta get the backlinks here. So I'm looking at this note. Like there are probably other ideas in here. Like we tend to think abstractly, could probably be elaborated on. Otherwise though, like I probably build ideas off of this, and really that's what I'll be waiting to happen. With so as I keep reading the book, I probably build on these ideas with things from the book as well, but then like still refer to these notes as well as the base in some way. But anyway, that's what makes the Zettelkasten a Zettelkasten, you know. I mean, like this for sure will be elaborated on. Like these are like the base, the foundational like knowledge. This will for sure be built on top of. this thing here, right? A formal standard of communication is useful for the sharing and dissemination of our knowledge and understandings. That could probably be a note in of itself. I just don't have it yet, and like don't have thoughts on that right now to elaborate on it. Like this as well could probably be the base for further thoughts on like, okay, then how can we make this more efficient or something? I don't know. And this too is like very, very simple. So yeah, I mean, lots of foundational notes right now, which to be fair is to be expected because like I don't have that many atoms right now. I don't know how I can see like a count. How about this? I have 153, but like they come from different areas as well. So yeah, it'd be interesting to see how like this web becomes more connected and like grows. But I think the issue right now is that I have a lot of source notes. I have 58, but only 150 atoms, which means like roughly 3 ideas per source note. Which like isn't necessarily bad, but my concern is definitely more with how like I have these clusters of just like purple things, which are source notes, which don't link to anything. And like at that point, it's not really doing me many favors, you know? Also, like, more yellows for the categories, that'd be good as well. Like, here's programming as a category. You can see that it's just an empty thing that just helps to link things together. I need to also organize those. But, yeah. Anyway. So, I would keep on this. Don't know how long it took me to finish the whole book, but I'll just keep going. Oh yeah, I don't know. Just keep going. Keep learning. Yeah. Check out. Probably make a playlist for this too, maybe? I might do. A category 3 playlist? Yeah, I might do that. So check that out for more videos on that.